Welcome to qnawire.
So now we'll work on problem 18 from chapter 20. In this problem, we're told for each of the following balanced oxidation-reduction reactions, identify the oxidation numbers for all the elements in the reactants and products and state the total number of electrons transferred in each reaction. So let's go ahead and write down our reactants here. So in the first reaction, we have 2Mn4- plus 3s2- plus water will produce 3 neutral sulfurs, 2 manganese oxides, and 8 OH anions. So now we're asked to write down the oxidation number of each of the reactants. So we know that for oxygen here it will be -2. So if we multiply that by 4, we get -8. And since the ion here is -1, we know that manganese should have a charge of +7. Here sulfur should be -2. Hydrogen will usually always be +1 and oxygen -2. And so sulfur here is 0 because it's neutral element. And then oxygen is -2 here, and manganese is +4 since we now have it a neutral element. And -2 for oxygen, +1 for hydrogen. So now in part 2, they ask us the total number of electrons transferred. And we can see that the redox reaction that's occurring here is we have 3 electrons being transferred from one manganese from sulfur to manganese. Manganese is gaining 3 electrons, and that happens for 2 manganese. So there are a total of 6 electrons transferred from sulfur to manganese. So for part B, the reaction is 4 hydrogen peroxide, H2O2, plus Cl2O7, plus 2 hydroxide, and this will produce 2 ClO2 minus, 5 waters, and 4 oxygen molecules. So we can go ahead and look at the oxidation numbers of each of these reactants. Hydrogen will be +1, and peroxides are unusual because the oxidation number of oxygen in peroxides is -1 instead of -2, so that's unusual. Here, Cl2O7, oxygen will be a -2 oxidation number, so that means -14, which means that each chlorine has to be +7. Oxygen in the hydroxide is -2, +1 for hydrogen. For chlorine, ClO2, we have -2 for the oxygen, which means that the chlorine has to be +3. And for water, +1 for hydrogen, -2 for oxygen, and for oxygen molecule, 0. So now we need to look at the total number of electrons transferred. Now to do that here, what we need to see is it's hard to track because we have some electrons coming from the oxygen, but we have hydrogen peroxide, we have Cl2O7, we have oxygen in each of these reactants. So it's hard to see exactly where the electrons are coming from, how many electrons are coming from oxygen. But what we can look at is how many electrons the chlorine is gaining. So we have 2 chlorines plus 7, and on the right we have 2 chlorines plus 3. So 4 electrons for each are gained. Here to here, we have 2 times 4 electrons. So that means there's a total of 8 electrons involved in this process. In part C, the reaction which we're given is barium 2 plus, 2 hydroxide, hydrogen peroxide H2O2, and 2 ClO2 minus ClO2. And then that produces a salt of barium, ClO2 minus, ClO2, and there's 2 of those. Then we have 2 waters and an oxygen molecule. So here we can put in our oxidation numbers. Barium is +2, as the superscript indicates. And oxygen for hydroxide will be -2, +1 for hydrogen, +1 for hydrogen, hydrogen peroxide, and -1 because it's a peroxide for oxygen. In the ClO2, we have -2 for oxygen, which means that chlorine has to be +4. In barium, we again have it as a +2. Chlorine here is a -2, which means, the oxygen is -2, which means that the chlorine has to be the same as before. In this case, it's not the same because over here we had a neutral molecule. Here we have a 2 plus here, which means that we have to have a negative here. So in this case, the chlorine will only be +3. Then hydrogen is +1, -2, and 0. Now we need to look for the total electrons transferred in this reaction. So we can look and see that once again from the ClO2 compound, we see that we have an addition of 1 electron here. And there's 2, so 2 times 1 electron, and that is coming from this oxygen here. So there are 2 electrons transferred.